A little bit of logistics this morning. Go ahead and write this information down just a little bit for everybody to, we're going to discuss the last test, and we're going to discuss whatever unit we're on right now. I can't look in your outline. I think it's unit 3. Or unit 4. Unit 4, right? Yeah, unit 3, we just put the test up on unit 3. So this is unit 4. I think we're going to have a test on unit 4 probably 2 weeks before the semester. I don't know. I don't know yet. So therefore, I don't know about the last test. But what I do know is the last test will start on the last day of class. And I'll give you until the end of the final week. And the final week is on there somewhere. So we'll get to it in a minute. Right now, I'm planning on the Unit 4 test. And then the last test may not be very much. It may be a little bit of Unit 5, which is the last unit. I really want to get to Unit 5 so you can tell your Calculus 3 teacher that you did get to Unit 5 or whatever. Stop at Unit 4. So I guess that's still up in the air. The last test, that's why I put question marks. But I want you to put down that it will start on the last day of class and last until the final exam. It'll start the same day the final exam starts, and it will end the same day the final exam starts. I have been known to do something special at the end of the semester. Watch for it. If I give you, well, let me just put it to you this way. If you're taking a test and the teacher gives you 20 points extra on the test, do you email the teacher and say, "Teacher, you gave me 20 extra points. You need to take those off"? Do you do that? Okay. If you see something on WebAssign and you go, "Golly, wonder why that is," you don't email me and say, "Hubert, I don't understand." You take advantage of it, okay? And anybody that's had me before probably knows what I'm talking about. But I usually do something at the end of the semester for everybody, and you just got to look for it. And if you see something that's kind of out of the ordinary, you go with it. Oh, I forgot. Skype people, can you hear me? Skype people, I need somebody to tell me if you can hear me.
I can hear you.
Awesome.
Yes.
Okay. Anybody not hear me, just tap it in the, well, you don't know, you can't hear me, then you don't know I'm asking, but if a question comes up or if somebody types in a question, let me know. I'm still trying to get Mr. Scobie in. He hadn't texted me back, so, okay, here he goes. Here, I can see the missed calls, but didn't see it ringing. Okay, let me try him again. Hold on. Let's see, there he is. I think, yeah, there he is. Mr. Scobie, you there? I guess he's there. Okay. Annabelle, you awful quiet. She went back to sleep too. Okay, Miss Bradshaw's there. Okay. Well. Okay, I think we got everybody now, except for Mr. Wisenhunt. I don't know if he's going to Skype in or not. All right, last day of class is April 26th. Your class meets on what? Tuesday and Thursday, so that will be your last day. If you look on your calendar, I believe that's on a Tuesday. So you need to put that down. That's the day that the homework will terminate, that your final exam will start, and your last test, whatever I cover up until that day, will start. Now, I'm not throwing out completely that we won't, this what we're on now won't be the last test. I don't know. It all depends on how far we get. So that's why I still have question marks beside the last test. Final exam will open on the 26th and last until May the 3rd. I will not extend because I have to turn in grades that next day because my department head wants grades turned in a day before. And I can understand that because when you got 20, 25 teachers, adjuncts, and full-time people, some of the adjuncts don't follow directions very well. And it causes a lot of problems when grades are not turned in when they're supposed to be turned in. So she has everybody turn them in a day before, so that way she can chase the ones that don't follow directions very well, and she has 24 hours before the registrar starts hollering. Okay? So don't even ask. If you've spent 8 days and you cannot get a test done in 8 days, then I'm not going to extend it. So make sure you get that done. Final exam will consist of all material I've covered. 2 attempts, highest grade, 25 to 33 questions, and 2 hours for the exam. Homework will terminate at midnight on the last day of class. Now, some of this is repetitive. There's a reason. Because I'm going to have somebody ask me, when's the homework turn off? So I'm not going to answer them, of course, because I'm going over it now. Now, this is very important because I need people to realize this. If you don't turn in a certain homework assignment, or if you don't turn in a group of homework assignments, that's going to affect your grade. I don't know why students think that since you're since you do all your homework online and all your tests online, that somehow the zeros have disappeared. And that doesn't happen. If you don't do the homework or if you don't do a test, you get a 0. And that's going to affect your grade. These people that come up to me after the last day of class and they say, my what do you call it? My grade dropped. I dropped down to a B. I don't understand. Well, you didn't turn in 2 sets of homework. So make sure you write down homework will terminate on the 26th, midnight. Grade book, your grade book on the do-jigger will have your grade calculated after you have completed all tests and homework. So if you want to have a good idea of what you got, then now I have set up grade book that it will round with 89.5, 79.5, and so on. So if you have above a 79.5 or equal to a 79.5, you'll get a B. And it'll automatically round that. After May 3rd, midnight, I will put in zeros for incomplete tests or exams. So if you have an incomplete, say like you didn't do the Unit 1 test, it's going to be a 0. This will also lower your grade. Make sure all assignments are completed, homework assignments, before the 26th, and make sure all your tests are completed before the 3rd. Okay? Does anybody have any questions about the last week of class or the last couple of weeks of class and exams? Anybody have a question? Yes, ma'am. I do it whenever I do it. And that's the surprise that the question was, when will I open up all the tests and homework to catch up on? That was the surprise. Miss Sheep just ruined the surprise. So whenever I do that, you'll see it. You'll see it you'll see the dates change. And when you see the dates change, that's when you say, oh, that's nice. I can go do this or I can go do that. Usually I do it the last week, somewhere around the last week. That's when I usually do it. Any other questions? Okay, make sure you write these dates down. Make sure that you make a note, a mental note, and don't ask no stupid questions the last week of class. And please do not ask for extensions, especially on the 3rd, because I can't do that. Okay? So make sure you have your stuff squared away. Any questions? All right. Now, yesterday, or whenever y'all were here, we went over curve length, or length of a curve, or length of an arc, or arc length, or whatever you want to call it, as well as the surface area. Now, that was a little bit getting you used to plugging and chugging with the derivative and the antiderivative. With chapter 10, you're going to be doing kind of a different, you're going to be using the derivatives, and you're going to be plugging the derivatives into a fraction and getting the derivative in respect to t. But I want to take a few minutes and talk about parametric equations. Unfortunately, I don't have a 3D video on parametric equations, or a little thing on the CD. But I want you to, if you have your book, I want you to get your book out. And if you don't, I'll pull it up here in just a second. But I want everybody to understand what a parametric equation is. Does anybody have any idea what a parametric equation is? Okay, nobody has any idea. Okay, that's fine. Well, I wasn't expecting anybody to answer it unless you're just weird. No, I'm just kidding. What is this? That's YouTube. There's the website. A parametric equation is an equation that is in terms of x, made up of x and y with a third component. And that third component is not z, it's not a third dimension, it's a thing that you cannot change. And what's the thing that you cannot change? Huh? Don't whisper. What is something that we have no control over? Nope. I've talked about it before, about the moms that go to the recitals and dress like they're teenagers. Time. We don't have no control over time. Have you ever been to a recital or a cheerleading competition? Some of y'all know what I'm talking about. It's really sad. But anyway, it is. It's really sad. What am I doing? I'm pulling up the book for y'all. And what I like to tell people is think about a car moving in a length, and no, not a car, but a plane. Think about a plane, a remote control plane, taking off and going in an X and Y direction. Now, we're not thinking about third dimension. That's Calc 3. Calc 3 is when you start getting into the third dimension, which is coming out of the board or going in another direction. And you've got a stopwatch in your hand. And you're timing that plane, that remote control plane, as it's coming up and going on an X and Y direction, you're timing it. That is a parametric equation. But you've got to think about that while you're talking about the parametric equation. A parametric equation is an equation that's in relation to time. All right, so, and that's what they're getting at right here with this squiggly line right here. It's not a function, but it's a parametric equation. Like that, and I hate to repeat myself, but in this case, I need to. Okay, it's not going to work. Okay, there we go. And here's your plane, remote control plane. And it's taken off, and it's going to, let's say, go like this. And this is a function because it's not all over the place, but I'm not trying to teach you a difficult parametric equation. I'm trying to start you off with a basic parametric equation. And you've got a stopwatch. Right here. Okay, there's your stopwatch. And at each point, now remember when I talked to you about derivatives, and I said you had to think out of the box, and I also talked to you about antiderivatives, and you had to think out of the box versus algebra. When you were in algebra, you had to think about a point, but in calculus, you have to think about a point in time. Remember me talking to you about that? Well, you've got to think about it like that. There's each little point, each little second on this graph is represented by in terms of time. And with each, and this is very hard to explain because I'm trying to start off basic. With each x and y, there's going to be a t. All right, and think of it as you're piloting that plane, and you want to know where you're at every second. Now, what you're going to be getting into is when you get into Calc 3. You're going to be adding that third dimension. And you're going to be having a point starting right here, and you're going to be talking about something like that, particle in space. And that particle in space is here, and it's here, and it's here, and it's here, and it's here. And I'm just going to draw a point right here. And you're going to pick a point right there. And that point's going to have a tangent line. And once it has a tangent line, then you can do a normal vector. And once you get the normal vector, you can get all the other type vectors that you need. All right, so, and again, you're talking about another parametric equation. You're talking about, and however you want to do this, some people do this as x and y and z coming out of the 4. But you're going to have x, y, and z, 2x plus 3z, or 3y minus 2z, and that's in respect to time. So if you're talking about a two-dimensional graph, you've got a third variable. If you're talking about a three-dimensional graph, you've got a fourth variable. But you can't treat it as a variable, as x, y, and z, but it's there. It's there, but it's not there. All right. Now, and I know I'm sounding redundant, but you've got to think of it as it's there, but it's not there when you're talking about parametric equations. All right. And that's all I can tell you. Now, on your calculator, and that's what 10.1 is. I really want you to read 10.1. I never ask y'all to read anything in here, but you really need to read 10.1 because 10.1, there's not any calculus in 10.1. There might be a little that refers to the calculus we've done, but there's no calculus as far as new calculus. This 10.1 is a reading section and a calculator, try it on your calculator section. All right? Take your calculator, if you got a calculator, and get it out. You can get it out if you want to. And And I don't know what y'all know, and I don't know what you don't know, so I'm not trying to insult your intelligence. But, hold on a second. Hold on. I don't know. Okay. Takir, you there? I lost Takir. Did I lose Takir? Yep. Well, he's just now coming in, which he does. Sorry about that. Y'all make sure Takir gets in there. I think he's coming in. All right. You got a TI or TI-89. It really doesn't matter which one you have. TI-89 is a little bit more calculus based. Who's that? Is that Takir? Who was that? Okay, it's Annabelle. Was that me? Okay, turn your speakers. I've turned something off. Okay, go to mode. And right here, down on the function, move it to parametric. And now hit y is equal. And if you notice, it asks you for an x and a y. Okay? And you're going to have to be thinking about x and y. Now the t's there because it's going to be in respect to 2. X is equal to 2t plus 7. Y is equal to 3t minus 4. Okay? And when you go to the TI-89, it's the same way. Mode. And change the function. I think you have to move to the right. There we go. Change it to parametric. And then hit y is equal here. And it asked you for, well, it didn't change it. Oh, I didn't hit save. Dork. Function. Parametric. Enter. And enter. There we go. And there, see, x of t, y sub t. X of t2, y sub t2. And you need to, your homework for 10.1, I don't think I'll put homework. I don't know if there's much homework I can put that's not just practicing. You go in and you type in, I'm just pulling one out of the book. X is equal to sine of 2t and y is equal to cosine of 2t. So sine of 2t, you'd hit sine, wherever sine is, and 2t, close parentheses, and y is equal to cosine of 2t. And graph. And of course you can zoom. What is it? It's not standard. What is it? I can't ever remember the zoom fit. There it is, zoom fit. 0. There we go. And it's a parametric in results time. And they're showing you, if you turn to the first page right here, and again, I don't know how much you've had of parametric. Somebody in my Calc 1 test, Calc 1, did I introduce y'all to parametrics in Calc 1? Say it one more time. I thought I did too. I remember talking about it. I might have talked about it with implicit differentiation. Did I, Mr. Huth or Annabelle, do you remember if I did parametric in Calc 1? Oh, they're going back.
I'm trying to think, but I'm not sure. I know, we did the airplane one, but we didn't do it where it was going out in the Z direction.
Yeah, but you remember us talking about it?
Yeah, maybe.
Okay. How about any other Skype people out there that didn't have me for Calc 1? Did y'all talk about parametrics? Okay. Them Skype people don't talk to me, except for one or two. All right. So I don't know what you know and what you don't know. But what I was fixing to show you is on the parametric, and this is a hard section to teach because it's bringing in that third quantity of time, and people kind of get confused. And that's why you need to actually, here we go, see what they're doing here? They're showing you how to actually plot a parametric curve. And I'm going to blow that up for you, and I'm just going to let you look at it. You don't have to do it or anything, as soon as I get everything out of the way. And notice that, what are you plugging in? T. You're plugging in T. You're not plugging in X, and you're not getting Y. You're plugging in T, and you're going to get X, and you're going to get Y. So all your equations are going to be X is equal to terms of T, and Y is equal to terms of T. You can't have X is equal to 2T plus Y. That would mess everything up. So 10.1 is actually what is a parametric equation, how do I graph them. It even talks about graphing devices and plugging in. You can make the cardioids and all that stuff. And I'll just show it to you. I'm not going to do it on the calculator. But if you turn the page over, for those of you that have a book, well, the next page, I think. Yeah. So if you want to make that one, excuse me, something's wrong with my voice this morning. X is equal to T plus the sine of 5T. And then you can make this one, or you can make this one. And it talks about how you can graph those. Question so far? So you have to get in the mindset of what a parametric equation is. Now, I'm on page, for those who's following, I'm on page 645. Now I'll just type it in, or just move over there. And I want you to make a note. The 645 must not be the same as, wow, must be a different book. About 3 pages off. There. Write that down. The derivative of y with respect to x is equal to as a y prime t over x prime t, or the derivative of y in respect to t over the derivative of x with respect to t. So you take the derivative of x, take the derivative of y, put the derivative of y over the derivative of x, and that's the derivative of x and y. Another way you can do it is what's called eliminating the parameter. I don't know if the book covers that, but I will show you how to do that also. I don't see it, but it probably mentions it. But eliminating the parameter, you can do that also. So, give you an example. I'm trying to find a simple example. Let's see. All right, x is equal to t squared, and y is equal to t to the third minus 3t. That's example 1. So I'll give you example 1. There it is right there. So I'll cut that out. Take it over to the handy dandy whiteboard. Go ahead and graph it on your calculators so you can see what it looks like. And then I want you to find the derivative of x in respect to y. Go ahead and graph your calculator. Get some kind of idea of what you're doing, and then we'll take the derivative, and then you're going to actually find out what the derivative is. I think out of all the sections that we've done, this unit right here is the one that is really expanding your thinking, because you're having to think out of the box. Now find the derivative. And let me tell you, you ought to have this taught to you and not explain the t variable. You're talking about a bunch of lost people. If you don't explain that t variable in a way that the students understand it, they'll flunk this test because they're not thinking about the t variable. They're trying to think about 3 variables and 2 unknowns, or 3 unknowns and 2 equations. And then they just quit. I'm just going to do it. I like the TI-83. I'm sorry, I never have liked the TI-89, so don't just get mad at me. All right, y is equal to t squared and t cubed minus 3t. And graph. Okay, didn't like that. Oh. There. Had a parenthesis in there. Zoom perfect or whatever, zoom fit. So we got some kind of, I'm going to zoom out a little bit. I just want to get a feel of what it looks like. Okay. Now, just to show you eliminating the parameter, I want to show you because you might see it. And remember in algebra when you did solving systems of equations, you did substitution. That's what you're doing. So in this case, solve for t. Oh, sorry. What the heck? So x is equal to t squared. T is equal to what? And what are you going to do with that square root of x? Plug it in, and you get y is equal to the square root of x, quantity cubed, minus 3 square root of x. Y is equal to exponent over index. That would be x to the what? Minus 3x to the what? And that's called eliminating the parameter. So you need to write that down and highlight it, because sometimes on the test or homework you're going to be asked to eliminate the parameter, and you just need to revert back to your algebra 2 skills of substitution. Now you can also graph that, and you'll see a relationship between this and that. Now, you may not see the exact curve that we get, but you'll see a relationship. In other words, like a parabola versus a half a parabola, because that t variable is in there. Now, take the derivative. Dx dy is equal to dy dt over dx dt. So you take the derivative of this guy, you take the derivative of this guy, and put this guy over this guy, and simplify. So, what's the derivative of dy dt? That would be what? 3t squared minus what? Over 2t. And that's the derivative. Now, let's remember, what is the derivative? What did we just find? That's not rhetorical, I'm asking y'all. What did we just find? I pulled a muscle in my back this morning, so I'm sorry. I don't know how I did it. What's that nerve in the back, down at the bottom of the back? What's it called? Psychotic? Something. Who knows what that muscle is called? Base of your back. Anyway, that's what it feels like. Right at the base of my back. It feels like a toothache. Okay, I'm still waiting. My Calc 1 students are letting me down. And all my Calc 2 students are letting me down because I can't remember what I told them the derivative was. The equation of the slope at what point? At any point on that what? Line. So if you want to take a point at 3, 0, I think they did that in the book. Y'all look and see. Three, 0. Didn't they do that? It says show that C has two tangents at point 3, 0. Yeah, that's what it says. Then you plug and chug. What? Do I have what back? Yes, I'm sorry. dy over dx. I'm sorry, dy over dx. I don't know why I did that. Because the y is on top. I don't know why I did that. There we go. So at 3, 0, 3, 0, so that would be 3 in the x direction. So somewhere right in here, you're finding the tangent line. I'm trying to write, it's not letting me do it because it's finding the tangent line right in there. I have to change it to this. Hold on. There we go. So if I take 3, 0, which is going to be right, well, that's x is equal to 3.3 right there where it's blinking, so we'll just use that. At that point right there, you're finding the tangent, you're finding the equation of the tangent line right there. And right here, you're finding the tangent line right there. And that's what you're doing when you're finding the derivative. Or question. Now again, it's not plugging and chugging like we did with the curve, but you can see how you're taking the derivatives and you're applying them another way. You're not plugging and chugging. What you're doing is you're taking the derivative of this and you're taking the derivative of that, and you're putting it in another function, and not a function, but another function, another entity like a fraction, and you're getting another derivative. Okay, so again, the theme is in Calc 3 that you're going to be taking derivatives and you're going to be taking antiderivatives, and then you're going to be taking those two things and you're going to be what? Putting them in something else, putting them in a formula, putting them in an equation, or whatever the case may be, putting them in a fraction, and you're going to be doing your algebra. Again, algebra is going to be a key to a lot of this.
So are there 3 tangents because there's 3 components of the equation?
I'm sorry, what?
Are there 3 tangent lines because there's 3 components of the equation? Like, why are there 3 tangent lines?
What 3 tangent lines? What are you talking about?
That's what all the book said. So that there's 3
4 bytes.
It says actually there's 3 tangent points. I can't figure out everything.
I'm looking. Probably because, oh, I know, because you have a third degree. That's why. Because of the t to the third power. That's why. And then when you didn't take the derivative, it turns down to 2, so it has 2 tangents. That's why. What else does it ask? Determine if the curve is concave upward or downward. You can tell that by looking at it. All right, let's try another one. It says find the tangent of r theta minus sine theta, r1 minus cosine theta. And that's example 2. Let me pull that up for you. All right, try that one right there. It says find the tangent to the cycloid. We'll go first, and you can put t in there if you want to. T and y if you want to. Or or you can put theta. I think the calculator has theta. You can do that. At the point where theta is pi over 3. So go ahead and find the derivative here and the derivative here and put it over itself, or put it over in the fraction. Now you got r times theta minus sine theta, and then r times 1 minus cosine theta. How do you take the derivative of those? Speak. To find the derivative?
You did that on the 8.
No, that's not the point. How do you do it by hand? Huh? How do you find the derivative of something being multiplied? Good job. Product rule. That coffee must be doing some good. You know, Ingles is going to put Starbucks. Is it Starbucks? And you don't know that? Oh, they do? I didn't know that. I'm on the land use board, and we got to approve the 81 Ingles and 24 Ingles to have Starbucks in it. I'm going to turn it down because I don't like Starbucks. Too liberal for me. And I'm just for it. I walked into that place one time to get a gift card, and I told myself I would never walk into that place again. It just reeked of bleeding hearts. And when you do the product rule, you get r sine theta over r times 1 minus cosine theta. Now, I'm just going to show you. I'm not going to do it. I'm just going to show you. Right here, you need to put product rule first times the derivative of the second plus the second times the derivative of the first, and it will reduce down to r sine theta. And same thing here. Basically get that. The r's do what? The r's cancel out. You get sine over 1 minus cosine theta. So again, is there any new calculus? No, there's no new calculus, but what you're doing is taking the old calculus and you're plugging it into something different. And of course they tell you to plug in pi over 3, and you see what you get. Now, do you remember your point slope equation? Anybody remember it? Y'all just don't want to talk to me this morning. Have I offended y'all or something? I offended y'all, that's what it is. Annabelle, you remember the point slope equation? Mr. Huss, do you remember the point slope equation? Is anybody going to talk to me this morning? Y'all suck. Y'all suck. Y minus y sub 1.
Yeah, Hubert, I remember it.
15 minutes later.
Neon, how it...
There you go.
Yeah, that's it. Sorry, I had to just get my other Skype
Thank
on.
you for confirming that, Annabelle.
You're welcome. Do I get an apple?
No.
Oh, darn.
I got an almond joy if you want one.
I'll take it.
I'll send it through Skype.
I'm kidding.
Why does, like when Patrick was in prison, and SpongeBob brought him a Krabby Patty and just shoved it through the phone? Y'all remember that? Now, y'all grew up on SpongeBob. Don't tell me y'all didn't watch SpongeBob. I watch it every day with my son. And sometimes when there's nothing on TV, I watch it. I record it for my son. He loves it. My daughter and son both grew up on SpongeBob. I don't see nothing wrong with it. All these people that say that SpongeBob and Patrick are gay, and I'm like, where do people come up with this stuff? The same people that said Bert and Ernie were gay. Y'all remember that? I think Squidward took after Bert. Think about it, they kind of sound like the same person. Do y'all know, how many of y'all seen the Shawshank Redemption? Do you know the guard? He's the voice of Mr. Krabs. The mean guard that beat up everybody, he's the voice of Mr. Krabs. I didn't know that. Why do I bring this up? Y minus y sub 1 is equal to m times x minus x sub 1. Okay? They're asking you for the equation. And remember back in Algebra 1, whenever you want to find the equation, and some of y'all that had me for Algebra 1, I know Annabelle did, whenever you see those words in the directions, find an equation, you're going to use some derivation or something having to do with the point slope equation. Again, you're taking your derivatives, you're finding a number, and you're taking it, plugging it into something that you know. I'm trying to get a theme going here. Hopefully y'all catching on to it. Questions? We're going to get into this more next week. All right, let's try nerd. We just did that one, right? Or did we? Is that the same one? Looks like the same one. Oh, find the area. We're not going to go there. Trying to find one in the homework. All right, how about I'll write one on the board. X is equal to 1 plus 4t minus t squared. X is equal to 1 plus 4t minus t squared. And y is equal to 2 minus t to the third. Y is equal to 2 minus t to the third. And find an equation. Go ahead and graph it, find the derivative, and find an equation where t is equal to 1. So our derivative dy dt is what? Negative what? 3t what? Over? Well, 4 minus 2t. Might help me out. Is that what y'all got? Okay, what do you do now? Well, x is equal to 1. So, I'm sorry, t is equal to 1. So I'm going to put x sub t is equal to 1 is equal to 1 plus 4 times 1 minus 1 squared. And that's going to be equal to 1 plus 4 is what? 5. 5 minus 1 is what? 4. So that's our x component. Y at t is equal to 1 is equal to 2 minus parentheses 2 cubed. And 2 minus 8 is what? I just made it up. Oh. 1. There, how about that? 2 minus 1 cubed is what? 2 or 1? Let's see. And then dy dt, that's going to be our slope at t is equal to 1, is equal to negative 3 parentheses squared over 4 minus 2 times the parentheses. And 1 squared, that's negative 3 over what? 4 minus 2 is 2. So our slope is equal to negative 3 halves. That's our slope. This is our, so I've got a point and a slope. What am I going to plug it into? Y is equal to point slope equation. X of 1, y sub 1. So y minus y sub 1 is equal to m times x minus x of 1. Y minus parentheses is equal to parentheses x minus parentheses. And y sub 1 is 1. M is negative 3 halves. And x of 1 is 4. Y minus 1 is equal to negative 3 halves. X plus 12 halves. 6. Somebody check my math there. And then add 1. Y is equal to negative 3 halves x plus 7. And that is the equation of the tangent line. That's a good example because you actually see what you're doing. All right, who has a question? So what did we just find? Yawning is not an answer. What did we just find? We just found the equation of the tangent line at what point? At time t is equal to 1. Or an x and y coordinate of 4, 1. So it kind of would help if you had it drawn on your calculator. So we're going to type in 1 plus 4t minus t squared. And 2 minus t cubed. And graph. And I'm going to blow that up, zoom, 0. And what is our point? 4, 1. Four, 1 should be up in here. It's right in there, probably where it starts. And basically, the negative 3x, 3 halves, what does that tell you? Yeah, it must loop around up here. We've got to pull it up. Zoom, pop in. Must have a little curl up there or something. Did I not have it in right? Yeah. See, there's the curl. Okay, check it. Is that right? And there's the curl. So let's find negative 4. I'm just going to use my trace, and I'm going to just get a point close to it. There's 4.09. So if you take your handy-dandy transparent board and lay it over it, and we're going to put a dot right there and take a red line and the equation of that red line is whatever we got while ago. And you can do that on any point. I'm sorry, what? Yeah, of this line right here, whatever. I don't have the whiteboard. I can't pull the whiteboard up right now. So If I wanted a point right here, if I wanted the tangent there, then you could find it. If I wanted the tangent here, you can find it. See a little dip right there? There's a little dip right there, so it might change. And that's why you have to blow it up. See, I didn't see the curl when we first started. There's a little curl right there. And see, that's why I wanted to go very slow, because if you go fast during the introduction of this, you're going to miss the whole point of what you're doing. And now, hopefully, you're saying, oh, I see what you're doing now. You're finding the difference between this and what we were doing in the first unit is you have that third variable. That's the difference. And next semester you're gonna have a fourth variable, and you gotta crawl before you can walk, and that's what we're doing. We're crawling right now for Calc 3. All right, let's do a narrative. Y is equal to t minus t to the negative 1 power. Let me put it on the whiteboard. Well, I can snip it out. Let me find it in the homework and I'll snip it out. There it is. Snip. Things I do for y'all. All right. Graphic. If I blow it up to where you can find that point, sketch it on your notes, draw a point, and draw a tangent line, and that's what you're finding. We're crawling some more. How we doing, Skype people? We doing okay out there?
Doing good.
Good.
Doing good.
10 minutes later. What y'all have to do? Wake up and get to the computer? Get out of bed and get to the computer? Oh, turn off the TV. That's probably what you need to do. Have to mute the TV and then you talk. X is equal to the square root of t. And y is equal to t squared minus 2t. Minus 8 is 8, right? So it should be 2 and 8. There's 2. So trace. Of t is equal to 4. Oops. Alright, so there's our point. T is equal to 4. So I'll take my handy dandy I don't know where it starts. Let's see. 0. T is equal to 0 is 0 and 0. So it starts from here. And I'm going to look at something like that. And they're looking at 2 and 8. So 1, 2, and 8 is right in here. So we're finding the equation of that line right there. The red line. So dy over dx equals dy over dt dx over dt. And that's going to be, our derivative of y is going to be 2t minus 2. And our derivative of x to the, or t to the 1/2 is what? 1/2 t to the what? Yep, 1/2 t to the negative 1/2. So, first of all, let's simplify that and multiply by 2 over 1 up here, right? When you divide a fraction by a fraction, you multiply by the reciprocal, so that'd be 2 times 2t minus 2 over t to the negative 1/2, right? Yes, no, maybe. Thank you, one person. And what can we do with the square root of t? Bring it up and we get 2 square root of t times 2t minus 2. And we could actually simplify that some more, because that t is to the 1/2 and this t is to the 2/2. So that'd be t to the what? 3/2? 4t to the 3/2 minus 4t to the 1/2, or you can put the radical in, either one. That's your answer. So, at this point, what? I'm sorry, what did you say? You figured it out? Okay, I forgot what I was doing now. Finding that t is equal to 4. Now, some people might go, oh, t is equal to 4. 1, 2, 3, 4. And that is a bad habit to get into. You can't do that. T is at where? T is out here on the stopwatch. And you have to think, okay, t is equal to 4. T is equal to 4 seconds. Or whatever. 4 milliseconds. Or whatever the t unit is. I've got to figure what? X and what? Y. And that's what we're fixing to do. So x at t is equal to 4 is going to be equal to the square root of 4, which is 2. So that's our x coordinate. And then y at t equals 4 is equal to 4 squared minus 2 times 4, which is 16 minus 8, which is what? 8. So there is our coordinate 2, 8 at what? T is equal to what? 4. And it's important that you understand that. If you don't understand that, if you're going, I don't understand, then you're missing some of the boat. So when this stopwatch is at 4 seconds, or 0.04, sorry. Let me fix it, somebody will say something. Okay, how's that? When that stopwatch is at 4 seconds, this particle in space is right there. And you want to find the tangent because later on you're going to find the normal vector, which the normal and tangent vector is based on the velocity. Think of the slingshot. David and Goliath, the slingshot going around and around and around. Well, that's what you're doing. Think of this as dang old slingshot going round and round and round. And you want to find the tangent vector and the normal vector so you know the velocity of the particle in space. So you take this, and then you take the 4, and you want to find m at t is equal to 4. So you plug it in right there. I think you should have left the radicals in there. Doesn't matter. You can plug it in here if you want to. So what's 2 times square root of 4? That's 8, right? Or 2 times 2 is 4. So that comes out to be 4. And then 2 times 4 is what? Huh? 2 times 4 is 8. 8 minus 2 is what? I'm plugging in 4. 2 times 4. Yeah, it's 8. 8 minus 2 is 6. 6 times 4 is 24. So m is what? 24. Y'all check, make sure I did it right. M is equal to 24 at what? At t is equal to 4. So now we've got this information, and we plug it into the point slope equation. So y minus 8 is equal to 24 times x minus 2. Y minus 8 is equal to 24x minus 48. Bring plus 8 over here. Y is equal to 24x plus what? Or minus what? 40. And you can tell by that 24 that that's a pretty steep what? It's a steep slope. So you could take, dang old, if you could lay y is equal to 2x plus 24x minus, let me do this and this, and put the dot right there. That's it, something like that. Okay, who has questions? All right, I know some of y'all may have thought, golly, that's easy, that's simple. But believe you me, I've seen a lot of students go through Calc 2 and have no idea what Chapter 10 is about. Well, 10.1 and 10.2. Because after 10.1 and 10.2, we get into polar coordinates and vectors. Okay? So I'm trying to give you this in little bits so you don't get overwhelmed. And I'm gonna put some problems on the homework. It's just gonna be what we did today. I'm not gonna get into area yet, and you can work on those along with your test and your Chapter 8 homework. Now you got some Chapter 10 homework, okay? Question? Nobody's got questions. I covered this so well that nobody has questions. Yeah, whatever. How about it, Skype people?